Okay, so let's take our statement and reason chart, copy what we have first. So AC and CE are equal, AB and DE are equal, and that was given. So if we kind of label this, AC and CE are the same, AB and DE are the same. Okay, so the next step in this, again, you interpret the givens if possible. There's nothing really to interpret here. So you can move on to making sure that all the elements from the end state are introduced. So we want BC. We have AC and AB, but we don't have BC. So we want to introduce that. I'd encourage you to introduce it by itself. So to say that BC is equal to, and BC again is part of a whole. So if you think of this as BC is a part of this whole AC, and it can be found by subtracting the other part AB from AC. Now, the advantage to that, or the reason for choosing this, is AB and AC are already introduced in your proof, so you're identifying or introducing BC in terms of the expressions that are already in your proof. And once again, just like the last one, this is still an example of segment addition, even though there's a subtraction in the problem. It's still the postulate segment addition. And we can introduce CD in the same step. CD is also a part of a whole. It's the whole CE minus the other part, DE. Okay, so once we get both of the end state elements introduced, we have the same process or steps that we did on the last one. And you can either transform one statement into the other, or you can create the equality of the expressions for BC and CD. I'll go through each of the examples. So let's say first we're going to take CD, and we're going to transform it so it's more similar to the expression for BC. So what can we replace CE with? Its equivalent AC. And what can we replace this DE with? Its equivalent AB. Okay, so when we're looking at that, that's simple substitution. We just substituted in two values for their equivalents. And now, by doing that, it creates this relationship that AC minus AB appears twice. And if two things are equal to the same thing, those are equal to each other. So we can make the statement BC and CD are equal by transitive property, which also is an example of substitution. Okay, so that's one possible way to complete this proof. The other possible way is we could have, instead of going in that direction, we could have taken the statement from step 1 now. So we could have taken statement AC is equal to CE. And here we could have removed, basically just subtract the second equation from the first. So if we subtract an AB from one side of the equation, we need to subtract its equivalent from the other. So either AB or its equivalent DE. And that would be an example of the subtraction property. Again, just subtracting the same value from both sides of the equation. And then here we take and we can now replace AC minus AB is equivalent to BC. CE minus DE is equivalent to CD. And so now we can directly substitute those in. So by substitution, we're able to identify the same end state in those two different manners. Okay?